Welcome back. In this session, we are going to discuss about decision tree by ID3 algorithm and common types of decision tree algorithms. So, common types of decision tree algorithms are iterative dichotomizer tree algorithm, C4.5 algorithm, classification and regression tree algorithm. Out of these three things, iterative dichotomizer tree algorithm is mainly used for classification problems and when the dataset contains only categorical attributes or features. And the main application of ID3 algorithms are to detect email spam or ham and to predict student pass or fail and then for used for customer purchase decision. And the splitting method that is used in ID3 algorithm are entropy and information gain. And while we are coming into C4.5 algorithm, it is an improved version of ID3 algorithm. It works well when dataset contains both categorical and numerical features. And the application of C4.5 algorithm is mainly used in medical diagnosis and credit approval and etc. And the splitting methodology in C4.5 algorithms uses gain ratio and it will handles mainly continuous values. If I need to add some special features to C4.5 algorithm, it handles missing values, uses pruning to reduce overfitting. And the third algorithm is classification regression type. It is used for both classification and regression problem. And its works well when dataset contains both categorical and numerical attributes. And the main application of CAT algorithms are house price prediction, disease classification, and loan risk prediction. And in this case, the splitting methodology is used here is it uses Gini index. And while getting into the tutorial, in this dataset, I'm going to use 14 rows and with 4 input features, namely outlook, temperature, humidity, and wind. And output feature is play tennis. For this particular dataset, I am going to use ID3 algorithm and plot a decision tree. Step number 1, we are going to extract the feature outlook alone. Let me focus only on outlook. In that outlook, the values we have are sunny, overcast, rain. And if you see the entropy formula, it is minus sum of p log 2 of p. And in this, when it is sunny, we need to look under outlook. We have total attributes is 14. Out of the 14, 9s and 5 no's. See the total entropy will be minus 9 by 14 log 2 into 9 by 14 minus of this category is for no. Minus 5 by 14 log 2 of 5 by 14 which is equal to 0.94 is the total entropy. And when it is sunny, how many s we have? If you look into sunny, we have two s's. One is here and another one is here. D9 and D11. And those two days you have 2s and remaining D1, D2 and D8 we have 3 no's. So entropy of SN which is equal to 0.971. Same way we need to calculate for remaining two outlooks, namely overcast and rain. If you look at the entropy of overcast, it is 0 and entropy of rain, S rain is equal to plus 0.971. So information gain formula is given for outlook which is equal to entropy of S minus summation of B belongs to sunny. You have three values: sunny, overcast, and rain, and mod of SV divided by mod of S into entropy of SV. When information gain S comma outlook, which is given by entropy of S minus 5 by 14. This 5, where it comes? It is comes from S sunny. Total value is here is 5 out of 14 attributes. We have only 5 that belongs to sunny. So 5 divided by 14, entropy of S sunny minus 14 divided by entropy of S overcast. This 4 comes from this S overcast. And this 5 by 14 comes from this S rain. And the information gain that you have achieved from this feature input feature outlook is 0.2464. Same way we need to calculate for temperature, humidity and wind. The values temperature which is equal to hot, mild and cool. These are the three values we have under temperature. So total attributes as we have calculated earlier, it is S which is equal to 0.94, and for entropy of hot, we need to look how many S's we have. We have two S's. One is here and another one is here. D3 and D13 we have S, and remaining twos are no. So entropy of S star which is equal to 1, and entropy of mild S mild which is equal to 0.9183, and entropy of S core which is equal to 0.8113. And as per our information gain formula, we are going to repeat the same equation. In that case, we will get Ig information gain of temperature is given as 0.030. We are going with future as humidity, and values under humidity are high and normal. As this S indicates the overall entropy as 0.94, and when high, entropy is high, it is 0.9852, and when entropy is normal, S normal it is 0.5916. So information gain S comma humidity which is equal to, I'm going to use the same formula, and in this case Ig information gain of entropy given humidity which is equal to 0.1516. Now we are going to compare for wind. For values of wind are strong and weak. So the total entropy is 0.94, and if you calculate for strong entropy, it will be equal to 1, and for high you have 6 Y's and 2 no's, so entropy of Si which is equal to 0.81. So information gain which is equal to entropy of S minus same formula, and if you calculate for information gain of S comma win, it is you will achieve as 0.0478. Now you are going to compare all the four information gains, and we need to choose which is higher, which contributes high information gain, so that we are going to consider it as a root node. In this case, if you see, the information gain of wind is 0.04, and information gain of humidity is 0.15, information gain of temperature is 0.03, and information gain of outlook is 0.2464. So out of these four values, which is higher? The first one. So we are going to choose this information gain of outlook have higher value. So we are going to consider outlook out of these four features: outlook, temperature, humidity and wind. We are going to consider outlook as a root node, and we are going to draw a decision tree. In Outlook, it comprises of data from D1, D2 till D14 with 9 Y's and 5 No's. In Outlook, we have three subvalues, namely sunny, overcast, rain. Under sunny, what are the data points that comes under sunny? Namely D1, D2, D8, D9 and D11. The data points that comes under overcast are D3, D7, D12 and D13. And if you see this overcast, under this overcast, out of these four data points, all those four data points comes under yes, and there is no zeros. So you can directly say the leaf node yes. And for rain, you have D4, D5, D6, D10 and D14. And out of these five data points, it says 3 yes and 2 no's. That means it is impure. And this overcast is pure data. And the sunny is impure. So under decision tree, we are using entropy and information gain to check how pure our data is at the leaf node. Now we need to check what term it will come on the term of this two question mark. This data. This data comes under sunny. Under sunny, we have only 5 data points, namely D1, D2, D8, D9 and D11 as per the previous chart. So in that again we are going to segregate this. So we are not going to consider the overcast, since this overcast comes under root node, we are going to omit that, and out of the remaining things are temperature, humidity and wind. In temperature, we need to calculate the overall entropy of sunny. Out of this 5, the entropy is 0.97. So in this 5 you have 2 yes and 3 no's. And entropy of hot and the temperature we have 3 values, namely hot, mild and cool. Out of this hot, mild and cool, we are going with hot first. So in this hot you don't have yes, we have only no's, 2 no's. So we have 0 y's and 2 no's. So entropy of S hot is equal to 0. So entropy of S mild which is equal to 1 and entropy of S cool which is equal to 0. Now we are going to calculate the information gain of S sunny given temperature which is equal to 0.570. Of feature as humidity, and under humidity we have two values, namely high and normal. The values for overall S sunny, the attributes, the entropy will be equal to 0.97. And for S high, under humidity, entropy of S high which is equal to 0, entropy of S normal which is equal to 0. So information gain of S sunny given humidity which is equal to 0.97. And after humidity, now it's time to calculate for input feature wind, and under the wind the values we have are strong and weak. So S sunny, the value is 0.97. It's overall entropy of S sunny, and S strong, the value is entropy of S strong which is equal to 1 and entropy of S weak which is equal to 0.9183. And we are going to calculate the information gain of S sunny given wind which is equal to 0.0192. Out of these three things, we need to calculate which one contributes higher information gain. So that will act as an internal node of left hand side. Correct? We are calculating only on sunny. So in this, if you look, the humidity wins that hold highest information gain. So we are going to have the humidity and as an internal node. After sunny, this parent of humidity will be outlook and through the branch of sunny. Under humidity, we could able to say how many data points were the high? We have D1, D2, D8. These three things says no, and when humidity is normal, data points D9 and D11 says yes. And now we need to calculate what will be the internal node for this case. So let me repeat the same process again. But in this case, what are the data points we need to consider? Only 5 data points, namely D4, D5, D6, D10 and D14 as I mentioned in the previous graph. The input features, apart from overcast, we need to choose the remaining 3, temperature, humidity and wind. The values under temperature are hot, mild and cool. After S rain, we need to calculate as 0.97 for S hot which is equal to 0 and entropy of S mild which is equal to 0.9183 and entropy of S cool which is equal to 1. And IG rain, temperature, that is information gain of S rain given temperature is equal to 0.0192. Namely, we need to calculate for remaining two things. Temperature over, now we are getting into feature as humidity. Under humidity we have two values, high and normal. And for S rain, the total entropy as we have calculated earlier, it will be 0.97 and entropy of S which is equal to 1. And in this case S normal 2S and 1 no. So if you see normals, we have 3 normals and out of these 3 you have 2 S's, 2S and 1 no. So entropy of S normal is equal to 0.9183. So information gain of S rain given humidity is equal to 0.0192. So after humidity we are now getting into wind. Under wind with the values we have a strong and weak. So as normal the total entropy of S which is equal to 0.97 and in this case S strong which is equal to, under strong we have only two total terms. Out of the two, all those two belongs to no. So there is 0 y and 2 no's. Entropy for S strong is 0, for entropy of S weak is also 0. Now information gain of S rain given wind which is equal to 0.97. Out of these three information gains, we are going to compare which one gives high value. Means if you look, information gain of wind plays a major role with a value of 0.97. So this term will act as an internal node on right hand side. So when wind is strong, the at values are D6 and D14 saying when wind is strong we should not play. So there is no yes in this case, it is pure data. So when wind is weak, it says yes, you can play. On which days? D4, D5 and D10 days we can play. And it says yes. This is how we need to draw a decision tree. Fine. I hope if you look at the bottom leaves, it will be all pure leaves. Thank you. We'll meet you once again in another video.